Yeah, good evening, all. I hope you're able to see the screen and my voice is audible. Can you please confirm me that?
Yeah.
Right, thank you. Thanks for your wait and welcome again. So for those of you who joined, this is the first session, like those who haven't joined yesterday's session and those who are joining this as the first session, welcome you all. So this is demo session 2, which is related to the batch 8 of GitHub Actions and Kubernetes. So in demo session 1, we have focused on what is the core syllabus of this entire batch, what are the different tools that are covered as part of batch 8 training program, and the complete full-scale level discussions what happened, mostly related to the core syllabus and the training modules. So those who have joined freshly today, just I'll give a recap of what we have discussed in the last session. So our batch is going to have 3 different modules. Module 1 will be focused on Kubernetes. Module 2 will be focused on GitHub Actions. Module 3 will be focused on GitHub Actions with Kubernetes, basically the projects. So in Module 1, that is Kubernetes, we are going to spend roughly around 40 to 45 hours, so which will spin up to 25 to 28 days of sessions, where we are going to talk about the in-depth concepts related to Kubernetes and monitoring aspect of the Kubernetes as well. And also the logging of the applications, the application logging, that is by using EFK stack or ELK stack. So that's something which is covered under Kubernetes. And in module 2, which is related to GitHub Actions, which will spin up to 20 to 25 hours or 18 to 25 hours, which will come roughly around 13 to 15 days or 16 days, where we are going to talk about a basic overview of CI and CD. How can we achieve CI and CD using GitHub Actions? And in the process of achieving CI and CD, what are the different things that we need to understand in the GitHub Actions? So on a top level, we have seen what are the core things that will be covered as part of the GitHub Actions module. And the last module, which is module 3, a combination of GitHub Actions and Kubernetes, where we are going to do 2 capstone projects on a large scale. If time permits, we'll do one more also. But 2 major projects which we are going to cover are a microservices application deployment. We will take a simple microservice application which has front-end, back-end, and database. And for each microservice, we are going to write the manifest files. We are going to include the databases. And then we'll deploy the application and we'll access the data in the databases as well. A kind of near real-time 3-tier application with microservices we are going to focus. And then we'll talk about the concept of a blue-green deployment by routing the traffic to whichever version of the application we need. If you want blue version, then we'll route the traffic to blue application. If you want the green version, we'll route the traffic to green version. That's basically the blue-green deployment. And if time permits, I'll be also focusing on 1-tier application deployment, which is basically the front-end part in the Kubernetes cluster with the GitHub integration, GitHub Actions integration. And coming to the fee structure of this entire training program, the fee structure is 7,000 rupees, which has to be made in 1 installment. But if you are looking to make in 2 installments, the fee will be 8,000 rupees, where on or before 2nd February, you need to make 4,000 rupees of payment. And after 15 days, that means from 2nd February, 15 days will be counted. So whichever day that comes on or before that day, the remaining 4,000 has to be paid. And the sessions will be there from Monday to Friday, and some days, even on Saturdays also will have a sessions, but that will be informed prior, at least 1 or 2 days before it will be informed, so that those who are joining the regular sessions, they can make the arrangements alternatively to be available on Saturdays. And the timings of the sessions is fixed, which is 5 to 6:30 p.m. as per Indian Standard Time. And whatever the session notes, whatever the YAML files, whatever the code the GitHub repositories that I'm going to use as part of the live sessions and also as part of the assignment task. Each and everything will be shared with you. Each and everything will be shared with you along with the recorded videos of all the sessions. So the recorded videos, the lecture notes, the GitHub repositories, everything, you can access it for lifetime. There is no limitation there. Once you get the access will stay till the end, till the very end. And coming to the payment of the fees, you can pay the fee to this particular number, either through PhonePe or through Google Pay. This is my personal number. You can also contact me if you have any questions, even after the sessions or just before registration. If you just want to confirm whether this is my actual number or not, you can just message me on WhatsApp as well. My WhatsApp number is also same. WhatsApp number is also same. So once you make the payment, please share the screenshot of the payment along with your name, email ID, and WhatsApp number so that I can use your WhatsApp number to add you in the dedicated WhatsApp group of batch 8 and also the community which is formed so far with all the batches that I have conducted. And email ID will be used to share the lecture notes, to share the recorded videos and all that part. And that's about something which we have discussed on a large scale in yesterday's session, that is demo session 1. Demo session 1. So in this session, that is demo session 2, we are going to focus on a couple of things. So the agenda of this session is we'll talk about what is meant by Docker. So in the process of working with Docker, we'll understand what is meant by containerization. What is meant by containerization? What is meant by a Docker file? What is meant by a Docker image and a Docker container? So logically, we'll talk about Docker workflow. So in order to work with Docker, what basic things that you need to know that workflow will look after. And then we'll deploy one HTML based application in the Docker container. And then we'll talk about the overview of Docker Compose as well. Overview of Docker Compose. These are the 5 topics which we are going to cover as part of this session. Once all these topics are done, then you are going to, I'll be taking your questions where I'll respond to your questions with answers accordingly. So please stay back till the very end of the session so that you'll understand the core essence of what all will be covered as part of batch 8 and what is the thing that we are looking for in this particular session. Those things also you'll try to understand. So first, let's understand about why do we need Docker? Why do we need Docker? That is basically the containerization concept. Why do we need it? Suppose, let's say, in real time, I might have different environments, or I'll have different environments, such as dev environment, test environment, or staging environment, and a production environment. Let's take 3 environments. Let's take the first environment as a dev environment, the second environment as a test environment, and the third environment as a production environment. Production, or like whatever you can say, that's fine. Production environment is there. Now, you are a DevOps engineer. You are a DevOps engineer. So as a DevOps engineer, it is your responsibility to set up the infrastructure which is required for all these environments. So in dev environments, logically, developers are going to work. Developers will work here. Developers will work. Let's say once developers develop the source code of the application, they have to test in their local environment, and that environment we'll call it as a dev environment. Dev environment. Once developers have written the code and they have tested in their own environment, they will send the code to the next team, which is basically the testing team. So testing team people will test the source code of the application by running the tests, the test cases. So here, test sets are going to work, or test sets will work here in the test environment. Once testing team is going to work, they'll also verify whether application is properly functioning or not, whether there is any code compatibility issues will come. So all of those things will be tested in the testing environment. Once the application is working successfully in the testing environment, then the code will be available in the GitHub repository for the DevOps engineers, where as a DevOps engineer, we are going to take that code and we are going to deploy into the production environment. So production environment is something where the DevOps engineer will work here on a large scale. DevOps engineer will work here. Now, as a DevOps engineer, what is your duty? As a DevOps engineer, your duty is to take the code from the GitHub repository, where you'll get an access, and accordingly you have to take the source code from the GitHub repository. That's the first and foremost activity as a DevOps engineer. And then once you take the code, you need to set up the infrastructure required. Let's say I need 10 instances. I need an EKS cluster. I need any other things like the VPCs, the security groups, the IAM roles. Whatever is required to deploy your application, we are responsible to set up the infrastructure. Once we set up the infrastructure, we need to automate the application deployment process. Now, how do we automate? In order to automate, we'll use CI/CD tools such as Jenkins, which is the most popular tool. And along with Jenkins, we also have GitHub Actions as well. That can also be considered as one of the automation tool for application deployment. But just because you have Jenkins and just because you have set up the Jenkins, automation doesn't happen. Assume that the application is a microservice-based application. Now for this, you have 3 microservices. Assume microservice 1, I'll call it as MS1 in simple. Microservice 2, and microservice 3. In real time, we'll have more microservices, but just for a basic idea, I'm just telling 3 microservices are there. So what developers do? Developers will write the source code for all of the microservices that are available for my application. Let's say I have a microservice called movies. Let's say the application is a Netflix application, kind of Netflix, Amazon Prime, whatever it is. We have the first microservice, which is movies. Second microservice, documentaries. Third microservice, let's say sports. 3 microservices are there. What developers do? Developers will write the source code for all the microservices. Now, as a DevOps engineer, what are you responsible for? You are responsible to write a Docker file for each microservice that is available for the application. You are responsible to write the Docker files for each microservice. Now, once you write the Docker file, using the Docker file, you need to build the Docker image. You need to build the image, and you need to push that image to the Docker Hub. Build and push the Docker image for that microservice. And this process is repeated for all the microservices that are there for your application. And then once the image is ready, then we need to write the Kubernetes YML files, the manifest files. Once you write the Kubernetes YML files with all the configurations, then you can use ingress controller or the different types of ingress controllers, the gateway APIs, whichever is required, we'll use that. And finally, all the microservices will be deployed into the Kubernetes cluster. into the Kubernetes cluster. So this is what on a large scale, as a DevOps engineer, you are going to do it in the real time. This is what on a large scale, as a DevOps engineer, you are going to do it in a real time. Okay. Now let's say for developers, I said that they need some servers. Why? They want to test their application, whether their application is working or not. Before developers send the code to the testing team, they have to test, or they will test usually in their environment. That means, what is an environment? Assume I need a server for this environment, for this team, dev team. Now, in this server, assume that I need to set up Tomcat, I need to set up Java, I need to set up Jenkins, I need to set up, let's say, generate the artifacts using Maven. Like this, I might have to do multiple configurations. If any other configurations are required, all those things has to be made. All those things has to be made. Now, similarly, assume that I have the test environment. So for test environment also, I need to create servers. In that servers, I need to do the configurations again. Now production environment, which is a live environment, again for that also we need servers, EC2 instances. In those EC2 instances also we need to do the configurations. Now you are doing these configurations in a manual way. Assume that you are doing all these configurations in a manual way, or you can use Ansible also for configuration management. I'm not touching Ansible at the moment. Let's say, as a DevOps engineer, who is responsible to create these servers for different environments? DevOps engineers are responsible. Who is responsible to do the configuration inside the servers? DevOps engineers are responsible. Who is responsible for the maintenance of these servers? DevOps engineers are responsible, because we are the one who is going to work with cloud and who is going to do the infrastructure setup for the application. Now think in this way, it is all manual process. Now assume that in dev environment, you have installed Tomcat 9.1 version. But whereas in test environment, you have installed Tomcat 9.2 version due to some issue or due to some mistake, you have installed Tomcat 9.2. In production environment, you have set up Tomcat 9.3 version. I'm just telling it as an example. In dev environment, you might have installed Java 17 version, or developers might have used Java 17 version. But in test environment, when you are setting up the test environment servers or the infrastructure of test environment, you might have installed Java 21. In the production environment, you might have installed Java 24. So that means there is a chance that configuration issues might get mistaken when you are working with different environments and when you are setting up the infrastructure for different environments. So if you do different configurations in each environment, what will happen? The compatibility issues will come. Those are called as code compatibility issues. Code compatibility issues might arise. So if code compatibility issues arises, the problem is we cannot deploy our application successfully into the servers. We cannot deploy our application successfully into the servers or into the environments. Now here is where Docker is going to come into picture. So what Docker will do is, Docker is a platform as a service type, PaaS. That is a platform as a service. Docker is a platform as a service type model. So Docker is going to provide you a platform to work with all of these things. Now, I want to set up all these infrastructure, the configurations, everything. Now, Docker will tell that you don't have to bother about the configurations. You don't have to bother about the configurations. Don't do any of these configurations. It's not required. It's not required. You write something which is called as a Docker file. You write something which is called as a Docker file. Now, what I'll do as a DevOps engineer, I'm going to write something called a Docker file. what this Docker file consists of? Docker file logically consists of all the configuration information to deploy our application. So Docker file is something which has the instructions, to deploy our applications. Now you will write one Docker file. For that, again, you have Docker file keywords like from, run, copy, arguments. Like this, we have different keywords. I believe you have an idea, so I'm not going to touch with that one. So we are going to write the Docker file. By using the Docker file, we are going to create a Docker image. As a DevOps engineer, you are going to create it. Now, this Docker image, I am going to share with the different teams or different environments that are available for my application. Different environments. Kindly mute yourself. I'm going to share it with the different environments that are available in my project deployment process or application deployment process. Now, once you have the Docker image, since every configuration is already configured inside the Docker image, you don't have to set up anything. Only thing that you have to do in each environment is by using this Docker image, you just have to create a container. That container is called as a Docker container. This is how to create a container, and that container we call it as a Docker container. Now, when you deploy your application in the Docker container, you don't have to bother about the configurations. Why? For all the environments, we are going to have the same Docker image. Same Docker image means same configuration in all the environments. Same configuration means no compatibility issues will come. So since the compatibility issues will not come, the testing of the application in the lower environments will become much simpler. That is what Docker is going to help us in order to do the application deployments and testing of the applications in the lower environments and also in the production environment. In the lower environments as well as in the production environments. Now, in order to write a Docker file, we have something called Docker file keywords or DSL keywords, domain specific language keywords. There are some 10 to 12 keywords are there. So I believe you have an idea about all of them. So I'll not touch that part. If I have to touch that one, again, it will take 1 to 1.5 hours of thing. So this is just an overview of Docker session. So that is how you are going to set up the different environments which are required for the application testing and application deployments in the real time using Docker. So for every application source code that you have, you will have a Docker file. By using that Docker file, you are going to create a Docker image. And that Docker image, we are going to store it in a Docker Hub. So what is a Docker Hub? Docker Hub is the place where we store the images, Docker images. Just like how we have GitHub to store the source code of the application, we can store the Docker images in the Docker Hub. Is it the only place? No. We can store the images in the AWS ECR, Elastic Container Registry. You can also store the images in Nexus as well. Nexus is basically an artifact repository tool, but still you can store your Docker images even in Nexus as well. So that is something which you need to do it. Okay, now you are clear that why do we need Docker? Now the thing is, let's understand how Docker will work. So that one, I'll call it as a Docker workflow. Let me just save this. Docker workflow. So how logically Docker is going to work? So that's something which we'll talk under the concept of workflow in Docker. Workflow in Docker. So whenever you want to work with Docker, primarily you need to have the source code of the application. Source code of the application. Again, that's something which will be given by the developers. We don't have to bother. Okay, once you have the source code of the application, it can be a microservice application, it can be a monolithic application, whatever it is. Once you have the source code of the application, as a DevOps engineer, you are responsible to write a Docker file for that. You are responsible to write a Docker file. By using the Docker file, you are responsible to create something called Docker image. You are responsible to create something which is called as Docker image. We'll use a Docker build command and we'll create Docker images. We'll create Docker images. So once Docker file is available, using the Docker file, we'll create a Docker image. Docker image. Once you have the Docker image, then we need to store this Docker image in Docker Hub or any place that is required. It can be in Docker Hub, it can be in Nexus, it can be in ECR, anywhere is fine. Once you have the image in the Docker Hub, then you are going to pull that image. We are going to pull that image. Let me keep it this way. We are going to pull that image wherever it is required or whichever environment that is required. We just pull that image. And once we pull that image, so let's keep it as pull the image. Once we pull that image, by using this particular image, we are going to create a container. We are going to create a container. That's what Docker workflow is all about. That's what the Docker workflow is all about. So have the source code of the application, write a Docker file. It is the duty of DevOps engineers to write the Docker file. Again, it's not just like that we'll write it. We'll take the help of developers also because we need to know some configurations from the developers as well. So we'll take inputs from the developers and then we'll write a Docker file. Once a Docker file is available, then by using the Docker file, we are going to build the Docker image. We are going to build the Docker image. So this is called as build process. We'll use a Docker build command, Docker build -t, image name, and then version. These things we'll give it and we'll build the Docker image. So once the Docker image is available, we are going to run the container. We're going to run the container. So how do we run the container? Docker run is the command. Docker run -it, -name. You will give the container name, image version, port mapping. All of these things we'll do, and we will create a container. So inside the container, we will have the application hosted. We'll have the application hosted. This is what Docker will do. Now, what we will do for a simpler understanding is, let us deploy a small scale application, which is an HTML application in the EC2 instance. And then we'll write one Docker file for that application. Then by using the Docker file, we are going to build the Docker image. We'll push that image to the Docker Hub, and then we'll create the container by using that particular Docker image. And then we'll see whether we can access the application or not. So this is what the Docker workflow is exactly, which we are going to follow in a while. So first we'll get the source code of the application from the GitHub repository. And then a Docker file will be written, build the image, run the container. So for that, we need to have an EC2 instance. So I'm currently there in the AWS cloud, particularly in the Mumbai region, in EC2 service. So let's launch one EC2 instance. I'm going to call that as Docker server. You can give any name to the instance. I'll be using Amazon Linux instance, which is 2023, the latest one. And instance type, I'll go with t2.micro. But if you have any other instance type, you can go with any instance type of your convenience. Because in the latest AWS accounts, you are not getting T2.micros, you're getting T3.micro or T2.small. That's something which you're getting. So whichever instance type you want, you can select it. Key pair, which is used to connect with the instance. You can either create a new key pair or you can select any one of the existing key pairs. So I'll select any one of the existing key pairs. And then security group, you can create a new security group or you can select the existing security group. So let's go with the creation of new security group, which is a launch wizard 5. That's a security group name. And then storage, let's keep it as 30 GB storage because we'll work with few things as well. And then number of instances, 1 instance. So I believe you have an idea about this one, how to launch an instance. So once the instance is launched, let us connect with this instance. Let us connect with this instance. So I'll select the instance, copy the public IP address. Now, in order to connect with that instance, I'm going to use MobiXterm as a tool to connect with that instance. In all our sessions, we are going to use MobiXterm only. If you are comfortable with Putty or Puttygen, if you are comfortable with Git Bash terminal, VS Code editor, anything of your convenience, you can connect. On end of the day, you should know how to connect with your instance. If that is there, that's fine. So that's a Linux instance. So username will be EC2 user, advanced settings, use private key, and then select the PEM file. So this is the PEM file, which is there for my instance. Once you have everything, then we are going to switch to the root user by using sudo su. Then we are going to update the packages. Once we update the packages, we are going to install Docker inside this instance. So let me get the Docker installation commands. Once we get the commands related to Docker, then we are going to install Docker. And then we will start working with the Docker file, image, and container creation. And then end of the day, we'll try to access our application. So that is the command to install Docker, minstall docker-y. And then we need to start Docker because Docker is a service. I told platform as a service. So we need to start Docker service by using sudo service Docker start. Once Docker service is started, then we can verify whether Docker is successfully installed or not. That also will do it. Just give me a second. I'll let it get installed and then we'll work with it. Yeah, that's it. Now the service is also started. Once the service is started, you can just do docker-v so that you'll get to know whether Docker is installed or not. So Docker is installed. So if you want to see the list of images, we have a command called Docker images. Currently, I don't have any images in my local. If you want to see the list of running containers, Docker ps is the command. I don't have any containers. If you want to see the list of running containers and also the stopped containers, that is all the containers I want to see, then Docker ps-a. I don't have any containers. Right. So let us install Git so that we can clone the source code of the application. Yum install git-y. Let me show you the source code of the application, which is available in my GitHub repository. If you want, you can also fork it when you are practicing, or even if you are not joining the sessions also, you can use that repositories. No issues with that. Right. Let me just go with ECR ECS project. So this is basically a HTML application only. Anyway, you will be seeing the different application types deployments in the Docker. That probably might have an idea. So I'll just copy the repository URL and then I'll go to EC2 instance, git clone, and then paste the repository URL so that the entire source code will be cloned to your local as in EC2 instance. Now ls, you can see the source repository. So switch to that repository, and inside this repository, we will have the different files. So basically, we have different HTML codes, contact.html, god.html, index.html, service.html. Like this, we have different HTML codes. Anyway, that developers will take care. You don't have to bother. What is your duty? Your duty is to bother about Docker file. Is to write about Docker file. So how do we write a Docker file? We'll have capital D, rest are all small letters without any spaces in between. Okay. Now let's write the Docker file. Before writing, let me delete everything that is there inside the Docker file. We'll write our own Docker file. Right. vi Docker file. Now I want to deploy an HTML application. HTML application. So if you want to deploy HTML application, we have two options. One is we can use Nginx, or the second one we can use Apache or HTTPD. Anything we can use, either Nginx or Apache or HTTPD. So let's say I want to use Nginx and I want to deploy the application into the Nginx web server. Nginx web server. So since I want to deploy the application in the Nginx web server, I need to pull the Nginx image. I need to pull the Nginx image. But if you are working with the Docker commands, we can use Docker pull image name. But I'm not working with Docker commands directly. I'm working with Docker file. So if you want to set up the base image for your application, we have a keyword which is called as from. This is called as from. So when you use from, what will happen is, whichever image that you want to pull, let's say I want to pull Nginx latest image. Nginx latest image. So it is going to pull that latest image as the base image for our application. And then I have the source code of the application. I have the source code of the application. Now, where is my source code? In my EC2 instance. I have the source code in my EC2 instance. Now, whatever the source code that is available in the EC2 instance, I want to copy that source code. I want to copy that source code to the default HTML location, which is available in the Nginx image. I want to copy the source code from my EC2 instance to the default location that is available in the Nginx web server. So since I want to copy, I use a copy keyword. What I want to copy? I want to copy the complete code. So dot. What does dot represent? Dot represents the complete code that is available in the local folder or in the current path of the working path. Current path. So dot represents a current location. So whatever files that are there in the current location, all those files has to be copied to where? To the HTML path of Nginx. Now, can anyone recall what is the default location where you will deploy the HTML code in the Nginx? Can anyone recall what?
Share Nginx.
Sorry?
USR share Nginx.
Yeah. So user share Nginx. Inside Nginx will have HTML. So whatever code that is there in the current location of my EC2 instance, I want to copy the complete code. Dot represents complete, every file. So I want to copy the complete code to this particular location. This particular location. That's it. Your code is copied. Once your code is copied, then you need to expose your application. I want to access the application in the browser. So how do we do that? For that, we'll write a keyword which is called as expose. So expose instruction will allow you to expose your application. Expose your application in the browser. So by default, this Nginx, Apache, HTTPD, these all things will run on a default port number, which is 80. Default port number, which is 80. So I'll give 80 as the port number to expose my application. Now, what is this port number? This is basically your container port. Your container port. So I'm exposing my container on port number 80, where application is available. That's it. This is your Docker file. This is your Docker file. Right. Now you have the Docker file. Now what you need to do is, by using this Docker file, we need to build the image. We need to build the image. So how are we going to build the image? How are we going to build the image? So in order to build the image, we are going to use a command which is called as a Docker build. We are going to use a command which is called as Docker build. Docker build. So let's use a Docker build -t. T represents a tag. This is my first image. So I'll just call it as image 1. Which version? Version 1. You can write any one, anything, any name of the image, any version of the image. So I'm trying to build an image with a name called image 1 with a tag called version 1. How do you build the image? Using the Docker file. Where is your Docker file? In the current location. So dot. If it's there in any other location, you have to give that path. Let's say it is there in /home/EC2 user/ECR repository. In this location, I have the Docker file. You have to give the explicit location if it is there in some other path. Since the Docker file is available in the path where I'm executing this particular command, I can use dot, because in the current location, I have the Docker file. So what Docker will do, Docker will connect with the Docker file. Docker will understand the instructions that we have written in the Docker file. If we have written all the instructions properly, then it is going to process those instructions from top to bottom. So first it will process this instruction, then this one, then this one, then this one. So Docker file instructions will be processed from top to bottom, so that once each and every instruction is processed, then we are going to have the Docker image. You see, I have written 3 instructions totally. First thing is it is going to pull the Nginx image. You see that one? From Nginx, it is going to pull that Nginx image. It is going to set up the base image for our application. Once it set up, then it is going to copy the source code. Copy the source code of the application. Now, once you run the container, you can expose your application to the outsiders. Let's verify whether image is available or not. Docker images. You can see the image was created 26 seconds ago. For every image, you'll have an image ID and the image name. Okay. Now, let's say I have the image. Now, by using this image, I want to create a container. By using this image, I want to create a container. So how do we create a container? So now, here 2 important things will come. Now, let's say I have an EC2 instance. Now, in this EC2 instance, I have installed Docker. Now, I have the Docker image in this instance. Now, by using the Docker image, I am going to create a Docker container. Assume this is your Docker container. In your EC2 instance, you can have multiple Docker containers also, no problem. So for time being, let us take only one container, because we need only one container for this application. That's more than sufficient. So this is your Docker container. So I'll call it as Docker container. Okay. So I have one Docker container. Now the question here is, as a user, let's say a user is available. As a user, how user will access the application? User is going to access the application from outside, from the browser. Where is your application? Application is running inside the container. Now, as a user, can the user directly access the application running inside the container? Can the user directly communicate with the container? It is not possible. Users cannot directly communicate with the containers. Now, how user should access? User will be able to access the application using the public IP address of the instance. You know that for every instance, we'll have the public IP address. So public IP : port number. So when user hits public IP : port number, then the traffic, whatever traffic that is there for the application, let me keep that in a little better way. Let's say user is accessing the application. So how user will hit the application? User will hit the application by using the public IP address of the instance. Okay. User will hit the public IP address and port number of the instance. Now, when you hit, as a user, when you hit this particular IP address and port number, how do you ensure that it is going to reach the correct container? Because in your EC2 instance, you might have multiple containers. So that means you need to reach, you need to ensure when user hits the IP address and port number, any IP address, it should reach the correct container so that an user can see the correct application. An user can see the correct application. Now, to achieve this flow, we have something called port mapping. We have something called port mapping. Port mapping. We need to map two types of ports here. One is called as a host port, and the second one is called as a container port. Host port, container port. Now, what is this host port and container port? Host means your EC2 instance. Your EC2 instance. Container port, your container port. Now, if you see the Docker file, in the Docker file, I have configured on which port your application should run. That is basically your container port. So I have configured the container port as port number 80. Container port as port number 80. This is my container port, which is port number 80. Port number 80. Okay, I have the container port. Now, the traffic should come to exactly this particular port. For that, you need to map the ports. With which port? Host port. Host port can be any port. Who is your host? EC2 instance. Who is your host? EC2 instance. Now let's say, I'll give some random port number. Container port you cannot change. Why? Container port is coming from the Docker file. It is already configured inside the Docker image. It is already configured in the Docker image. So you cannot change that. So container port, you should not change. Host port, your EC2 instance port number, any port you can give. That is called as a port mapping. That is called as port mapping. So how do we do that port mapping? How do we do that port mapping? So let's understand the port mapping concept. Let's do the port map. Docker run. I want to create a container. So we'll use a Docker run command and -itd. I don't want to log into the container. So I want to run the container in a detached mode. You can directly give -d also, no problem. -itd also you can give. Detached mode means I don't want to log into the container. So -itd or -d, anything you can use. Docker run -itd. What I want to run? Container. Name of the container. Let's say I'll call, I'll call this container as Kastro -container. Any name, whatever name you want, you can give that. And in order to create a container, what do we need? We need an image. We need an image. Do we have the image? Yes, sir. Image 1. Which version of the image? Version 1. Now, if you do this, what will happen? Container will get created. Container will get created. But you cannot access the application running inside the container. Why? You didn't do the port mapping. You didn't do the port mapping. Now, let's do the port mapping. So how do we do the port mapping? -p, which represents a port mapping. Host port. What is your host port? Your EC2 instance port. Your EC2 instance port. Let's say I'll give the host port as 80. Any number you can give, 8080, 9090, 70, 60, whatever number you want, you can give it. Host port you can change according to your convenience. Container port. What is my container port? In the Docker file, I have configured. By using the Docker file, I have configured the Docker image. So in the Docker image, the container port is configured as 80. This is basically a port mapping. Now hit enter. The container will get created and container is accessible. On a port number 80. So this is my host port. Now, what is the host port? Your instance port number. So when user wants to access the application, how will he access or how will she access? Public IP :80. So when public IP or instance :80, what is this 80? Not container port, host port. Can you change the host port? Yes, you can change, no problem. So when you hit this particular IP address as a user, when you hit this particular IP address, how the traffic will go? The traffic will be forwarded to your container where you have mapped with the container port. host port you have mapped with container port, no? You have mapped. So it will reach to exact that container. From that container, you are going to get the response. You're going to get the response. Let's see whether that will happen or not. So now we have the instance. For that instance, we have the security group. In the security group of that instance, we are going to edit the inbound rules by adding a port number 80, anywhere IPv4, save rules. Now, copy the public IP address of the instance and paste it in the browser, :80. If you don't give 80 also, no problem. Hit enter. You should be able to see the application. You should be able to see the application. You see that? This is how simple the application deployment will become. Application deployment will become. I'll give this IP address in the chat box of the meeting. You can also try whether this application is reachable or not. You can also try whether this application is reachable for you also or not. Yeah. You can check it from your end also, and you can let me know whether application is accessible or not. Is it accessible? Can anyone please confirm?
Yes.
Right. So that is how the application can be deployed into the Docker container. Now, where is your application? Inside the Docker container. Now, same application, can I deploy on different host port? Yes, you can deploy. But container port, can I change? You cannot. Let's say Docker run -IDD. I'll give a new container name, hyphen name. Let's say container 2. I'm creating a new container called container 2. And how am I creating this container? Using the image. Which image? Image 1. Which version? Version 1. Now for this one, I want to do port mapping. So -p host port. I can give any port. Let's say 90. I'll give this time. Any number 9090 also you can give. And then what is your container port? Container port is 80. Container port you should not change. Host port you can change. Hit enter. Now do Docker PS. You'll have a second container. So whenever user is going to access the application using this host port, where the traffic will be routed on? The traffic will be routed to your container port. Your container port. Let's do the same thing. I'll just open port number 9090 in the security group of that instance. And then we'll try to access the same application on this particular port as well. Let me, anywhere IPv4, save rules. I'll take the same instance, same public IP, :9090. Hit enter. Same application is also running on different container. Now, where these containers are there, all of these containers are there in the single EC2 instance. Single EC2 instance. That is how you can deploy the applications into the Docker containers. Okay, we are successfully deploying the applications into the Docker container. But why do we need to learn Kubernetes then? Why do we need to learn Kubernetes? Now, using Docker, we can create the images. We can create the images. We can push the images to Docker Hub. We can push the images to Docker Hub. And then we can create the containers. We can create the containers. That means application deployments can be done. But the thing is, we cannot manage the containers. Let's say I am getting too much of traffic for my application. Now this one container is not sufficient to handle the traffic. I need to increase the containers. I need to scale up and scale down the number of containers. I want to scale up and scale down the containers. And then I want to perform the load balancing between containers. I want to ensure high availability for my containers. Let's say if someone accidentally deletes this container should get recreated automatically, so that you'll have high availability for your application. You cannot achieve all of these things just by working with Docker. You need to know something called container orchestration. That is a management of containers. Container orchestration. What is meant by container orchestration? Management of containers. So how do you manage the containers? For that, we have something called container orchestration tools. Container orchestration tools. What are some of the most popular orchestration tools? Docker Swarm is one of the oldest one, and in the olden days, it was popular tool also for management of containers. But Docker Swarm also has its own limitations. Docker Swarm cannot perform the load balancing. In Docker Swarm, cannot actually do the auto scaling. You cannot give high level of security to your containers. So there are some security lapses that will be there when you work with a Docker Swarm cluster or Docker Swarm concept. So this is the oldest one where nobody is going to prefer in the real-time scenarios. Now the advanced one is Kubernetes. The advanced one is Kubernetes. So where we are going to manage our containers in the form of pods, PODS, pods. We call them as Kubernetes pods. Kubernetes pods. So Kubernetes has a much better advantages than Docker Swarm. Now, if you have a question like, okay, in that case, I can just learn Kubernetes, no? So why do we need Docker to learn? Because end of the day, in the Kubernetes, you are going to configure Docker images. You're going to configure Docker images. So if you want to configure the Docker images, you should know how to build an image. I mean, you should know how to write a Docker file, how to build an image, how to tag that image, how to push that image, The Docker essentials are very important. Docker concepts are very important. Without understanding Docker, Kubernetes will become little difficult. Little difficult as in, you should know how to write a Docker file, build the image, push that image to Docker Hub. In Kubernetes, the very simple thing that we can do is, you have the image in Docker Hub, take that image and configure in the Kubernetes manifest files. Once you configure in the Kubernetes manifest file, automatically Kubernetes is going to pull the images. Kubernetes is going to pull the images and then applications can be successfully deployed. And that is what exactly we are going to focus from next session, which is going to happen from Monday. That is on 2nd February. So from 2nd February, we are going to focus completely on understanding about Kubernetes, how to manage the containers, how to orchestrate means management, how to manage the containers that are running for our application, how to scale up the containers, how to set the limit quotas, limit ranges, how to work with config map secrets, how to attach the volumes, all of these things, how to perform the load balancing, all of these things will be focused as part of Kubernetes. So this is something which I wanted to tell as part of this particular session. But what is this Docker Composer? Docker Compose is something which is like automating the image creation and container creation. Anyway, again, we don't use Docker Compose in the real-time scenarios. It is all about Kubernetes only, where end of the day, all your applications will be deployed into the Kubernetes cluster. But Docker Compose is used to, let's say I have a microservice application. For all the microservices, I need to build the image and I need to create the containers. Let's say I have 10 microservices. For each microservice, building the image and creating the containers in a manual way is a complex and time-taking process. So if you want to automate the image creation and the container creation, we will use a Docker Compose. It's like an advanced version of working with Docker. The advanced version of working with Docker Compose is Docker Swarm. The much better and enhanced version of Docker Swarm is Kubernetes. So remember, Kubernetes is not a replacement to Docker. Docker has to be there when you are working with Kubernetes. You need to know how to create the image, how to build the image, how to write a Docker file. These things, if you know, as far as Docker is concerned, that's more than sufficient to understand Kubernetes. Anyway, in Kubernetes, we'll just take the images from the Docker Hub and then we'll deploy our applications. Right. So that is all from my end for this particular session. Before I take any of your questions, as I said earlier, so the fee structure is 7,000 rupees. So those who wants to register for this training, which is going to happen from Monday, you can complete your payment onto this number, which is 97007 12459, either through PhonePe or through Google Pay. If any international students are there or candidates are there, you can ping me on WhatsApp on the same number, where I can share you the PayPal link also. You can do the payment using that one if you are from international transaction. I mean, if you are doing international transaction. And once you make the payment, you will be added to the WhatsApp group, and all other details will be shared with you personally and also in the WhatsApp group regarding the next session, which is going to happen from Monday. So please complete your payment on or before Monday, let's say before 12 o'clock in the afternoon or 1 o'clock in the afternoon, so that if you do the last minute payments, I may not be able to respond immediately because session will be happening. And if you respond when session is happening, I may not be able to send you the link. You may miss out the session. Anyway, recorded videos and all will be available. But still, if you want to listen the live session from day one itself, so please complete your payment on or before Sunday itself. Don't even keep it till Monday also. Try to finish it off before Monday. That is before 1 o'clock in the afternoon. You try to complete your payment so that for me also I'll get some time to verify your details and to verify the payments, and then I can add you in the WhatsApp group and I can send you the separate meeting link for rest of the sessions. So that all will be updated in the WhatsApp group and also personally communicated with you as well. Yeah. So that's from my end. If you have any questions, you can keep your questions now. Any questions for anyone?
From Monday, we'll be directly starting with the Kubernetes.
Yes.
Yeah.
Yes.
Okay. In AWS, right, Kiran?
Yeah, AWS.
Yeah, okay. Yeah, sure. Okay. Thank you.
So we are taking EKS cluster. So do you cover cluster admin, like adding nodes, removing nodes?
Yes. In the process of working with cluster, we are going to set up the worker nodes also.
Okay.
Yeah, rancher will not be covered.
Okay. So why I ask this, like, to while showcasing, so we can say that we have with prior knowledge cluster admin.
Yeah, cluster setup you will be doing. Without cluster setup, nothing can be done. So cluster setup will be shown in the first 2-3 sessions. Cluster setup will be shown. Once the cluster is ready, and once you know how to set up the cluster, then only we'll start working in the cluster.
Okay, thank you.
Right. Okay, then. Thank you all. Thanks for joining. So those who wants to complete the payment, you can ping me on WhatsApp before making the payment, or you can directly do the payment and you can share the details. Anyway, this video will be uploaded to the YouTube also. It's a public video only. And in the description of this video, you'll be able to find the registration details and my contact number also. You can ping me using those details as well. Yeah. Thank you all. Thank you once again. I hope to see you all from Monday.
Thank you.